A container ship leaves a Chinese port loaded with something that looks almost boring on paper. Solar panels, aluminum frames, silicon cells, inverters packed in uniform crates. No flags, no military escort, no headlines. But if you trace where those panels end up, Texas, Gujarat, Andalusia, Northern Africa, you start to notice something uncomfortable. The energy transition isn't just a climate story. It's a supply chain map that leans heavily in one direction. China currently produces over 80% of the world's solar photovoltaic modules, according to the International Energy Agency's 2024 supply chain report. Not just assembly, the full stack, polysilicon refining, wafer production, cell manufacturing, is concentrated in one industrial ecosystem. That concentration matters more than most policy debates admit, because solar energy isn't like oil, where you can reroute shipments or switch suppliers relatively quickly. Once a country installs solar infrastructure at scale, it commits to decades of maintenance cycles tied to that original manufacturing base. And this is where the uncomfortable layer begins to form. The United States talks about energy independence. Europe talks about green sovereignty. But both are scaling systems whose upstream supply chain still runs through Chinese industrial capacity. Now, I'm not saying there's a switch that Beijing flips to turn off the sun. That's the lazy version of this conversation. Reality is slower, more structural, less cinematic. Power here doesn't come from interruption. It comes from replacement friction. Let me explain what I mean. A solar farm installed in 2026 isn't just an energy asset. It's a long-term dependency loop. Panels degrade, inverters fail, efficiency drops. Every maintenance cycle pulls procurement back into the same supply chain unless you rebuild the entire manufacturing ecosystem domestically, which takes years, sometimes decades. The US Inflation Reduction Act, for example, is trying to break that loop. Billions in subsidies for domestic clean energy manufacturing. But even with aggressive investment, scaling upstream silicon refinement is not something you compress into a political cycle. Meanwhile, China didn't just get ahead in solar manufacturing. It treated it as an industrial policy priority for nearly 2 decades, integrating state financing, cheap energy inputs, and vertical consolidation in ways that competitors didn't match. There's a detail most people miss in this story. China doesn't need to weaponize solar panels aggressively for them to function as leverage. The structure itself does part of the work. Because when a country depends on imported infrastructure for its energy transition, any disruption, price shifts, export controls, shipping delays, doesn't just affect trade. It affects decarbonization timelines, electricity pricing, and political credibility. And that creates pressure without a single overt threat being issued. In 2023, when China introduced export licensing requirements on certain graphite and silicon-related technologies, markets reacted immediately. Not because supply stopped, but because policymakers realized how thin the margin of substitution actually was. That reaction tells you more than any official statement. But here's where the picture gets more complicated, and where I'm not fully convinced by the dominant Western framing either. Because dependency is not the same as control. The assumption that China can automatically convert manufacturing dominance into geopolitical coercion ignores something important. Global energy systems are not static targets. They adapt, slowly but persistently, often in ways that erode the original advantage. Still, adaptation takes time, and time is where leverage actually lives. The real question is not whether solar panels are being weaponized in a direct sense. It's whether the transition period, this 10 to 20-year window where the world is rebuilding its energy infrastructure, naturally concentrates bargaining power in the hands of whoever controls the bottleneck industries. And right now, that bottleneck is not oil, it's silicon. There's a second layer to this that almost nobody wants to say out loud yet, and it sits between industrial policy and national security planning. But before we go there, we need to understand how this dependency actually behaves when it moves from spreadsheets into real political decisions, because that's where the theory starts to either hold or collapse. There's a moment in every large system where efficiency quietly turns into dependence, and nobody announces it while it's happening. Solar didn't arrive as a geopolitical issue. It arrived as a cost curve. In the early 2000s, the obsession was simple: get solar cheap enough to compete with coal without subsidies. China's industrial machine did that faster than anyone expected. The result wasn't just cheaper panels. It was a global procurement habit that locked in scale advantages for a single production base. By the time governments started talking about energy security and clean tech, the purchasing decisions had already been made for them at corporate level. Now, zoom into how that dependency actually forms. A solar module isn't a standalone product. It's the end point of a layered chain: polysilicon refining, ingot casting, wafer slicing, cell fabrication, module assembly. Each stage is capital intensive, and each stage gets cheaper when it sits next to the others. China didn't just dominate one layer, it stacked them in the same geography, often within the same industrial clusters in provinces like Jiangsu and Xinjiang. That matters because in manufacturing, proximity is not convenience, it is cost compression. And cost compression becomes political gravity. The United States and Europe didn't lose solar manufacturing because of a single decision. They lost it because each incremental outsourcing step looked rational at the time. A factory closure in 2012 wasn't framed as strategic decline. It was framed as market efficiency. This is where the counter-argument usually comes in. Markets chose China because China was cheaper. And that's partially true, but it ignores the scale of state-backed acceleration that made cheap structurally stable rather than temporary. Chinese industrial policy didn't just subsidize production. It reduced uncertainty for producers across the entire supply chain. Long-term credit lines from state banks, guaranteed energy inputs, coordinated land allocation for industrial parks. That kind of systemic support doesn't show up in a simple price comparison, but it compounds over time. And compounding is the part that matters. Because once global installers, utilities, and developers standardized on Chinese supply, the switching cost stopped being just financial. It became logistical. Engineering standards, procurement systems, maintenance training, all optimized around one dominant supplier ecosystem. This is where dependency stops looking like trade and starts looking like architecture. Now, there's a historical parallel that's useful but imperfect. In the 20th century, oil created similar strategic asymmetries. But oil had a built-in redundancy: multiple exporting regions, shipping routes, and substitutable grades. Solar supply chains are more brittle in a different way, not because they are fragile in operation, but because they are concentrated in production stages that are not easily replicated without rebuilding entire industrial ecosystems. The interesting twist is that China's position in solar is not just about exports, it's about embeddedness. Even when panels are assembled elsewhere, critical components often trace back to Chinese manufacturing inputs. That creates a loop that's hard to see in trade statistics alone. And it leads to something most policy discussions underplay: time lag vulnerability. If a country wanted to reduce dependence today, it doesn't get immediate payoff. It gets a decade of transition where costs are higher, supply is less stable, and rollout slows. That creates domestic political friction long before strategic independence is achieved. So even de-risking becomes a politically expensive decision. Now, I want to pause on something important here, because the narrative can drift too easily into inevitability, like China owns the solar transition. That's not accurate, and it misses how fragile industrial dominance actually is over long horizons. Manufacturing concentration is powerful, but it is also historically self-correcting when it becomes strategically visible. Governments react, capital reallocates, new supply chains emerge under pressure. But, and this is the part that matters, that correction is not instantaneous. It moves at the speed of factories, not headlines. And during that gap, leverage exists. Not as control, not as a switch, more like a delay embedded into the system. The uncomfortable question is what happens if multiple regions try to escape that dependency at the same time, while still needing massive solar expansion to meet climate targets. Because then the system stops being a simple supplier-consumer model and starts looking like competition over who can rebuild faster without slowing down their own transition. And that tension is where the real strategic story begins to form, not in trade wars, but in industrial timing. We'll need to go one layer deeper into how this plays out when policy pressure meets physical supply constraints, and why some of the assumptions about rapid reshoring don't survive contact with reality. There's a habit in policy circles right now that sounds confident on paper. Assume supply chains can be rebalanced if incentives are strong enough. But solar manufacturing doesn't behave like software migration. It behaves like heavy industry with memory. It remembers where it was built because every stage depends on the last one being physically nearby, economically stable, and technically synchronized. The US Department of Energy has been explicit about this in multiple supply chain assessments. Rebuilding upstream solar capacity domestically requires not just factories, but parallel expansion in refined silicon, specialty glass, silver paste production, and precision tooling. Remove one layer and the rest slows down. That's not ideological, it's mechanical. Now, the complication. China's dominance isn't evenly distributed. It is strongest in upstream and midstream segments, polysilicon, wafers, cells, but less absolute in downstream installation markets. The world still installs solar in fragmented, localized ways. Rooftops in Europe, utility-scale farms in India, hybrid grids in the Middle East. So the system is split between global production concentration and local deployment dispersion. That split creates a strange asymmetry. The world can adopt solar quickly, but cannot easily reproduce the system that makes solar cheap. This is where the dependency becomes politically sensitive, because when prices are low, the geopolitical question disappears. No parliament debates where polysilicon is refined when electricity bills are falling. But when supply tightens, even slightly, that question reappears with force. We saw a small version of this during the 2021 to 2022 supply chain disruptions. Freight costs spiked, module prices temporarily increased, project timelines slipped across multiple continents. Not because solar failed, but because the margins assumed in energy transition models were thinner than expected. And that's the point most people miss. Solar scale-up is not just about capacity. It's about predictability of inputs over 20 to 25-year investment cycles. Now let's challenge the more aggressive interpretation for a moment. Some analysts argue China is deliberately structuring this dominance as strategic leverage, a kind of soft coercion over the global energy transition. The argument sounds neat, but it struggles under scrutiny. If control were the goal, you would expect active restriction of exports or consistent price manipulation. What we actually observe is closer to export expansion, overcapacity cycles, and intense internal competition among Chinese producers themselves. That doesn't map cleanly onto a coordinated weaponization model. But absence of intent doesn't mean absence of effect. That distinction matters, because systemic leverage can emerge without central design, especially in industries where scale advantages compound faster than policy coordination on the buyer side. Now, there's another layer here that rarely gets discussed with precision: substitution delay. Even if the US or Europe successfully expand domestic manufacturing, they still face a lag before those factories reach cost parity. During that lag, imported panels remain economically dominant, which means policy cannot simply switch supply chains. It must subsidize the transition while continuing to rely on the existing one. That is not dependency in a binary sense. It's staged dependency. And staged dependency is politically unstable because it looks like vulnerability at the exact moment governments are claiming progress. Here's where things get more uncomfortable. The global push for decarbonization is not slowing down to accommodate supply chain restructuring. In fact, it is accelerating. Net zero targets are tightening timelines. Electricity demand is rising due to electrification and AI infrastructure growth. The system needs more solar, not less. So demand pressure is moving faster than manufacturing diversification. That gap is the real tension point. And it creates a window where one production ecosystem, already scaled, already optimized, continues to supply a disproportionate share of global expansion. Not because anyone agreed to it, because no one could fully replace it in time. Now, I want to be careful here. This isn't a story of permanent dominance. Industrial history rarely allows that. The US lost and regained semiconductor capacity influence multiple times. Japan once dominated memory chips before being displaced. These shifts happen, but they don't happen evenly. They happen in phases of advantage, erosion, and replacement. And the middle phase is where geopolitical discomfort peaks. We are sitting in that middle phase for solar. And the question is no longer whether diversification will happen. It will. The question is what global energy pricing, grid stability, and climate timelines look like while that diversification is still incomplete. That's where policy optimism meets physical constraint. And the gap between those two is where most strategic misreads begin. We're close now to the part where this stops being an industrial story and becomes a strategic forecasting problem, because timing, not technology, starts deciding outcomes. At this point, the story stops being about solar panels as products and starts being about solar panels as time. Not time in a poetic sense, time as in installation schedules, grid expansion deadlines, election cycles, and the slow grind of factory ramp-ups that don't care about political urgency. There's a mismatch building in the system, and it's subtle enough that you only notice it when you line up three separate realities side by side. First reality. Global demand for electricity is rising faster than most long-range forecasts expected. Electrification of transport, industrial reshoring, and data infrastructure expansion, especially AI-heavy computing, are all pulling power demand upward. Second reality. Solar remains the cheapest, scalable new energy source in many regions, according to repeated International Energy Agency cost benchmarks. That keeps demand structurally locked in. Third reality. Upstream manufacturing for solar is still heavily concentrated in China's industrial ecosystem, even as other regions begin building alternatives. Individually, none of these are alarming. Together, they create a timing imbalance. And timing is where strategic leverage quietly appears. Now, I don't think this should be framed as China holding the world's energy transition hostage. That framing is too clean, too intentional. It assumes a level of centralized orchestration that doesn't match what we see in the data. What we do see is something messier. A globally accelerated energy transition colliding with a manufacturing base that scaled earlier, faster, and more completely than its competitors. And once that happens, dependency doesn't feel like dependence. It feels like arithmetic. If solar expansion is urgent, and politically it is, then the lowest cost, fastest available supply chain dominates purchasing decisions, even when policymakers are actively trying to diversify. That's the contradiction sitting at the center of this entire system. Now here's where I'll be direct about my own read on this. I don't think solar manufacturing dominance translates into clean geopolitical control. Not in the way oil once did for certain exporting states. The structure is too fragmented on the demand side, and the technology too widely distributed in its end use. But I do think it creates something more uncomfortable for policymakers: constrained optionality during a period when they are publicly committing to maximum speed on decarbonization. That gap between ambition and industrial reality is where leverage lives, not as coercion, as delay pressure. And delay pressure is politically expensive in democracies that have tied climate credibility to visible infrastructure rollout. Now zoom forward a few years. If current investment trends continue, and this is the prediction I'm willing to stand behind, we will likely see partial reshoring of solar manufacturing in the US and Europe, but not full independence. The system will become more diversified, yes, but still structurally interdependent at the silicon and wafer level. China's share will probably decline at the margin, but remain dominant in critical upstream segments longer than most political timelines assume. Not because others fail, because scaling industrial ecosystems takes longer than scaling political expectations. And that mismatch will define the next phase of clean energy geopolitics more than any single export policy or tariff decision. There's one more uncomfortable implication here. If global electricity demand keeps accelerating, then solar doesn't just remain a climate solution, it becomes a baseline infrastructure necessity. And once something becomes a necessity at scale, the question shifts from who produces it to who can produce it reliably under pressure. That's a very different kind of competition. So the ending isn't a conclusion about China winning or America catching up. It's a more unstable picture, a world where the energy transition is real, fast, and irreversible, but built on supply chains that are still catching up to the speed of that transition. And the final thought I keep coming back to is simple. If the future grid is increasingly solar dependent, then control isn't about owning the sun. It's about who can industrialize time itself. And I'm not convinced anyone has fully solved that yet. If anything, I suspect the next major shock in this space won't come from politics directly. It'll come from a moment when demand accelerates just a little faster than the factories can respond. And that's usually when systems stop feeling theoretical and start becoming political in real time. If you want, next time we can go deeper into the semiconductor side of this same logic, because the structure rhymes more than most people realize.